we have already analyzed what happens at this point, point D. At this point, we have the external reaction, 2.69, 2.69, 12.69. And then we have DE, this bar, and that bar. So we apply these equations, and we have that DC equals 14.75, DE equals 7.3, and DY is this vertical force, 12.69, that we calculated with the moment equilibrium here. So now we have to keep going. So we have analyzed what point D is. Now the next point can be point C. So I'm going to copy everything that I find at point C. Copy. And I'm going to move it here. Okay, so that will be C. What's the name of the bars? We have DC, that bar here. That happens to be this one. That's DC. And this is CE. CE. And that one, it's CB. Okay, because it goes from point C to point B. DC is not an unknown because we know it. This force is 10. It's the external force applied at this point. And then we have to calculate these two bars. And we know that the angle, it's always, in this case, all angles are 60 because it's an equilateral triangle. So all angles are 60. Good. DC, we know the value, but what's the direction? So DC, when we calculated this, when we are analyzing point D, DC moves towards the point. Okay, so if we're analyzing the other point D, DC moves towards the point. So if we have the arrowhead, it's the other way around. Okay, so DC goes in this direction. Why? Because in this case, it goes in this direction. Okay, so DC always moves towards the point. If we're analyzing point D, we have this arrowhead here. If we're analyzing point C, we have this arrowhead here. Okay, the value is 14.75. Here we have 10. And then we have CE and CB. What is the direction of these two? I don't know. So I'm going to let the software decide. In this case, we go in this direction. And in this case, we go in that direction. I think it's going to be wrong, but let's start the equations. And if we have a negative number, is that the arrow should point at a different direction. Okay, so vertical and horizontal. Copy this one. Vertical equilibrium and horizontal equilibrium. Get rid of all these. And horizontal. So what's the vertical? Well, there are a lot of things here. We have this DC, so we will have a vertical component of DC. We will have a vertical component of CE, and we have this force 10 going down. Okay, so in vertical, let's start with everything that goes down first. So 10 goes down. Plus, what else goes down? The vertical component of CE. And what is the vertical component of CE? It's CE times sine 60. So this is CE sine 60. And now what goes up? DC, the vertical component of DC, and this angle will be 62, DC sine 60. That's the equation of the vertical equilibrium. And now we have the horizontal equilibrium. So for the horizontal, we have three things. We have the bar CB. We have the horizontal component of DC, which is DC cosine 60. And we have the horizontal component of CE. That will be CE cosine 60. And according to this drawing, everything is going leftwards. That doesn't make any sense, but let's solve the equation that way. Okay, so what is the first thing that goes left? CB plus. CB it's horizontal, so we don't have any sine, cosine, it's just horizontal, so it's CB. Now the horizontal component of CE is CE cosine 60 plus CE cosine 60. And the horizontal component of DC is DC cosine 60. Okay. And equals what? Well, instead of DC, I'm going to type 14.75. Because this is 14.75. Equals what? If we don't have anything else, 0. So there will be one of these forces with a negative sign, okay? Because we don't have anything here, so either this one or that one, it will have a negative sign, or both, I don't know. Okay, so this equation, here we have two unknowns, CE and DC, and here we have, well, see, DC is not an unknown because it's 14.75. This is 14.75. So here we can calculate CE. CE equals, it's, okay, it's 14.75 sine 60. Now this 10 that we have here, it goes to the other side with a negative sign. And then we have to divide this by sine 60. So we divide everything. Divide by sine 60. So if I'm not wrong, this is it. What? Okay, so we have 14.75 times sine 60. This goes to that side of the equation, negative 10. And then we only have this CE divided times sine 60. So we divide everything. That's why I have the parentheses here, divided by sine 60. Let's start putting numbers on this. It's 14. It's 14.75 times, and now I have to open the parentheses, 60 trigonometry sine, close parentheses. So this is 12.77 minus 10 divided by parentheses sine 60, first 60, then trigonometry sine, close parentheses. And there you go. So this is 3.2 That's CE. So CE equals 3.2. CE. Now, if we have CE, we can calculate CB. What we have to do, we have to move this here with a negative sign, and then we have to move this here with a negative sign too, because we want to solve CB. CB equals negative 14.75 cosine 60 minus CE, it's 3.2 cosine 60. That's it, isn't it? Yep. So CB equals, this is a negative number and this is a negative number, and I have replaced CE by 3.2. Okay, so let's solve this one. It's negative 0, negative. Okay, let's do 14.75 times parentheses 60 cosine. Okay, so that number, it's 7.375. So I'm going to go step by step. So CB equals negative this, and that will be negative 3.2 cosine 60. 3.2 times parentheses 60 cosine. There you go. This is 1.6. Okay, so this is negative 1.6. So how much is this? CB, CR, CB equals negative 7.375 minus, or negative 1.6. So this is 1.6. We need a negative sign, so I'm going to multiply times negative 1. Let's do this. 7.375 plus 1.6. It's 8.975 negative. So CB is negative 8.975. So that means that CB is this number, but with a different direction. So I can rotate this one, and CB is 8.975. Okay, so now that I have the right direction, it doesn't have to be a negative number. And finally, we have CE. Oh, CE is 3.20. Okay, so CE is 3.20. Since it's a positive number, we don't have to change the direction. So that's the, yeah, that makes sense. Now we have this going right, that goes left, that goes left too. And yeah, and yeah, the horizontal component of CE plus the horizontal component of DC equals CB. And then the vertical component of this and the vertical component of that. Okay, so there's a balance here. Can we do this with a graphic? I think we can. If we or this one, we'll copy this because I want to create a polygon and I want to close that polygon. So this goes. Okay, what am I doing? I'm using this, but I'm drawing the force with at the right scale. Okay, so if this is 10, I have to draw a line going down, and the value is 10. If this one is 14.75, this one. So, but we have to follow this. So this is the first force, then this is the second force, that is the third, and that is the fourth. So at the end, we have to create a closed polygon. And if we start here, then after drawing all these forces, we have to end here too. Okay, so this is 10, then we go 14.75 up in this direction. And what's next? The next one will be a direction like this. And finally, there will be a horizontal force here. Okay, and now we have to trim because we go down, then we go like this. This is CE, and then there's an intersection here, and we have to go that way. So we have to chamfer this one and that one. If we take the measurements of this force and this force, this should be 3.2, and this should be 8.9. I think it makes sense, but I want to make sure that I'm doing this okay. Dimension aligned. This is 8.97. And now I have to take that dimension aligned, this one and that one. It's 3.2. Okay. So I think this is a good criteria to understand what we are doing. Imagine that we are doing the same thing with this one. Okay, so what do we have here? We have this force. It goes up from this point. It goes up 2.69. Then the following table, the following bar is this one, is DE, and DE is 7.3. And then we have that one going down. So if it goes down, this is 14.6 or 14.7, doesn't matter. Okay. So that's it. Well, I made a small mistake. I considered that this is 14.65, and here this is 14.75. Well, it should be 0.65, so this is my mistake. But anyway, it doesn't matter. So with this one, we have solved these point, and the next one will be point B. I'm going to copy everything that we have at point B. Okay, copy. It's here. So this force is 12. At point B. This force is 12. Now this is CB, and CB is first. Where is it? CB is moving towards the point, and that's the value. Okay, so if it moves or if it points at this point, on the other side, it will point at the other point. So the arrowhead is like this. Okay, and why is it going towards point B? Because in this case, it goes towards point C. Okay, if we are analyzing this point, the vector goes in this direction. If we are analyzing the other point, the vector goes in the other direction. And now we don't know where these two, so we let this decide. And well, most likely this is wrong because we don't have anything going down, everything goes up. So either this one or that one, it will go down. Okay, so now you have to solve point B. I will do that in another video, but once you get what happens at point D, point C, then we have point B, and then we only need A and E. We can start with point A, and then we can go in this direction. The value should be the same.